This one's already factored, so I don't have to do any work to try to find my x-intercepts. Please, if you're trying to do this on a test, you are wasting your time. If you're trying to do second calc 0, your zeros are already given to you here. Make sure that you're stating your multiplicities. These are important because that will help you recognize where things should bounce and where things should cross. So right now my y-intercepts is a little bit harder to do, so we'll try to have the calculator do that for us. But our x-intercepts, so from the factored form we can see that we have -1 with a multiplicity of 2, -3, and 2. So we don't have to find those x-intercepts with our calculator, we just want to try to find the y-intercept and our turning points. This should also give us an idea of what our end behavior should look like as well. I have unselected my y1 and selected my y2. I'm going to go to my zoom feature and do zoom standard and see what my graph looks like. Looks like I can see most of it. I don't see the top of that, so I am going to have to change my y max a little bit. I'm going to go to a y max of 20 and see if that allows me to see the rest of my graph, which it does. So I already have those x-intercepts. I do not have to find those zeros. As we can see, we bounced at -1 because that has a multiplicity of 2. It also seems like that is one of our relative minimums, our only relative minimum. So we're not going to waste time trying to find that. Let's find our two maxes. One is relative and one is absolute. And let's find our y-intercept. Gives us a y-intercept of 6. We could have done that the old-fashioned way by plugging in 0 for x, but our calculator did it for us. So we know our x-intercept is 6. And then let's find our two maximums. There's one of our maximums. This one is our relative max. And that is another maximum. This one is the absolute highest that the graph goes. So we would consider this our absolute max. So now we're going to take a second and transfer this information to our Smart Notebook. So for this one, we found our y-intercept of 0, 6. We found our two other turning points other than that -1 that had a multiplicity of 2, which was a turning point. Based off of our calculator graph, we say that our end behavior was both -infinity. If we were to do it the long way, we would see that our leading terms would multiply to something that had an even degree with a negative coefficient, which means the same end behavior as we got for our graph. Take a second and sketch this with your turning points so that we can talk about increasing and decreasing. So I connected the dots to the best of my ability. My pen did die, so forgive me with that. So work with me. I typically like to try to also label each of the points just so that we show you that we want to see that as well, to make sure we know what point you're finding. So your extremas are those turning points. We specifically have two maximums. One of them is a relative max, which is at, and we have an absolute max at 16.306. Do not report your absolute min as -infinity. We do not want that, but do report your relative min of 0. We are increasing from -infinity all the way to that first max, that relative max, at -2.397. So we go down until the relative min, where we start increasing again to the absolute max. And then after the absolute max, we start decreasing again. So again, your decreasing happens in between where your increasing happens. So we increase from negative infinity to negative 2.397. We're going to decrease between negative 2.397 and the min at negative 1. And then after the absolute max, we decrease again. So we decrease from that x value of that absolute max all the way to the right to positive infinity. Remember, increasing and decreasing deal with your x values. So domain and range, domain for these polynomial functions is always negative infinity to infinity. The range for this is going to depend upon whether it opens up or down. For your even degree, it opens down, so we go from negative infinity to your absolute max. Your absolute max for this problem was 16.306, so that is what your range will be. It is based off of the absolute max or absolute min, depending upon the problem. So here's two examples of what we will expect from you. One in standard form, one in factored form. These are the ways to go about it, utilizing your calculator as well as previous knowledge.